Today, we will discuss about a very fundamental concept of thermal physics, internal energy. Say, we have a box that is filled with gas molecules. These are the gas molecules. Suppose the gas consists of diatomic molecules only. These are the atoms of the diatomic molecule, and the spring represents the bond between the atoms. Let's talk about the kinetic energy of this diatomic molecule and its atoms. The diatomic molecule can have translational motion in any direction in this container at ordinary temperature. The atoms of the molecules can rotate about an axis which passes through the center of mass of this molecule. This rotational motion exists in ordinary temperature too. At high temperature, the atoms of the molecule vibrate about their equilibrium position. This is the equilibrium position. The vibration occurs like this. Due to these three types of motions, the total kinetic energy of the microscopic components, that is the atoms and the molecules of this gas, includes translational kinetic energy, rotational kinetic energy and vibrational kinetic energy. Let's talk about the potential energy of this molecule and its atoms. There is a vibrational potential energy associated with the force between the atoms of this molecule at high temperature when the atoms of the molecule vibrate about the equilibrium position. The molecules of the container interact with each other as there is charged components inside them. There is an electrical potential energy associated with such interaction. So, the total potential energy of the microscopic components of this gas includes vibrational potential energy and electrical potential energy. The internal energy of this gas is defined as the sum of the total kinetic energy of the microscopic components and the total potential energy of the microscopic components of this gas. For any object, the internal energy is defined as the sum of the total kinetic energy and the total potential energy of the object's atoms and molecules, one thing we have to keep in mind that internal energy is defined when there is no net motion of the system. That is, the system is viewed from a static reference frame with respect to the center of mass of the system. We have seen for diatomic gas, kinetic energy has these three components and potential energy has these two components. But for every object, the kinetic energy of microscopic components and the potential energy of the microscopic components do not include all of this. For example, an ideal monoatomic gas has random translational motion only. That is, the molecules of an ideal monatomic gas has random translational motion only. So, the total energy of its microscopic components consists of random translational kinetic energy only. Now, how many components the total energy, how many components the total kinetic energy of the microscopic components and the total potential energy of the microscopic components will have depends on the molecular structure of the matter. We have told that diatomic molecule has vibrational kinetic energy and vibrational potential energy at high temperature. So, at high temperature their total energy is higher than their total energy in ordinary temperature. As temperature decreases, internal energy decreases. As temperature increases, internal energy increases. But the relation between internal energy and temperature is limited. Internal energy also changes when physical changes, for example, phase changes occur.